Hi, everyone, and welcome to Cloud Native Live for Wednesday, July 31st. I am Taylor Thomas, a CNCF ambassador, your host today. Cloud Native Live is a great opportunity for everyone to learn about basically the nuts and bolts of cloud native technology. So that's everything from how the things are made, demos of how it works. It's just really to get people involved and to understand like what are the cool things out there that you can do. And as this is a cloud native event, it is a cloud native CNCF event. It is a governed by the CNCF Code of Conduct, which basically boils down to be respectful to each other. So please make sure to keep your comments and everything respectful. We encourage and look forward to any questions and chatting that might go on, and we'll try to answer those as much as we can in flight. So with us today, we have Jochen and Tyler, and I'll let them introduce themselves, and then we'll go ahead and kick off.
Yeah, hi, my name is Jochen Rau. I'm the engineering manager for the platform team at Machine Metrics, a small IoT company. And Tyler is one of my team members.
Yep. Yeah, I'm Tyler. Like Johan said, I'm a member of the platform team, senior engineer at Machine Metrics, doing some cool stuff with some cloud native tech.
Awesome. Thanks. We're excited to have you here. And actually, today I am also one of the presenters. I'm not just the host. So today we're talking about wasmCloud and Wasm quite a bit. So wasmCloud is a CNCF project, but I'm going to go ahead and just I'm going to give some of the background because some people might not know what WebAssembly is. So I'm going to show some hopefully helpful diagrams, and then really just let Jochen and Tyler kind of show the cool things that they're doing. We invited them along. They've been pretty long time wasmCloud community members at this point and have done a lot of cool demos and things with it. And we figured after talking to them that their use case would just be really cool to show because it's IoT and edge and other things. So we'll get to hear a lot from them. But first you'll hear from me. So we'll go ahead and start off with just a quick diagram of like, well, what is WebAssembly? Like, and this is one of the diagrams that has most helped us with explaining this. So we have these various things along here where we're trying to understand like, well, what is WebAssembly? So WebAssembly, you'll hear all of us WebAssembly community people say it. I've said it a bajillion times, probably even on this stream once or twice, that WebAssembly is neither web nor is it assembly. It's actually just a compile target. And what it lets you do is compile for basically a platform agnostic way. It's very small. It's very lightweight. It's entirely sandboxed because its first home was in the web. And so because everything's sandboxed, it means that you have to basically grant permissions for it to do anything. It's a very good security model. Now, what is one of the things that people have a hard time understanding is like, well, where does it fit in? Is it just like a lighter weight container? And so this diagram here is hopefully just to help do that. We kind of started, like, there's this kind of like evolution of computing that we've gone through. And we started with bare metal servers. Everything was on a blade in a data center. And before blades, even things before that, like where you had like a full like 1U server that was in there. And you would install everything on there. You had like your actual operating system, the libraries for it, and then you ran all those applications on top of those libraries. And then we decided, well, what if we made this like better and virtualized it? And so we came up with virtual machines as an industry, and we could say, well, now we just have individual machines, but they all have their operating system, their libraries, and their applications. And that's where containers came in. Containers made it a lot easier to make things basically portable or packageable. You now package your applications and libraries on top of a container image that could then be run across Kubernetes or any other thing that can run a container. But the problem is your libraries and things were still coupled to your application. So you might have 10 different containers that are all a similar Java Spring Boot app, but they might have 10 different versions of a dependency. And so this led to lots and lots of security problems and issues, and also just duplication. We call these non-functional requirements. Now, WebAssembly components, which I'll explain a little bit more about in a second, are the ability to say, like, well, what if we pull away those non-functional requirements and libraries can be pulled away from the user-provided business logic and be pluggable. You can reuse the same library for multiple things. And that's what WebAssembly lets you do. It lets you focus on that business logic. This component model, which I'll show, is really the key to that, and it makes this a very, very powerful and compelling technology, which you'll see a lot of from Jochen and Tyler in just a second about why that's so important. But it's entirely cross-platform, not like the things you have with Docker, where you have to build separate images for each one. You build a single target, and then you're able to run it on each of those machines and then compose these things together. So with that in mind, let's go ahead and explain what's the component model. So over here on the right is a big piece of the component model. It's called WIT, Wasm interface types. This is a part of a standard of the component model. This is all done in standards groups, W3C and a couple others. And this is a standard format that everybody can use. And you can kind of equate it to like an open API definition. It's not exactly the same, but the component model gives you three big things. Everything is interface driven. The example you see on the right is a key value interface. So, I mean, it's a pretty standard set of functionality. You can get more than this, and you can always create your own custom interfaces to do so. But like, there's a common one we call WASI key value, and this lets you say, I'm going to get a key at such and such with such and such name, or set a key with a name, or whatever it might be, the standard behavior you'd expect. So everything is interface driven, rather than deciding like when you start a project, I'm going to use Redis, or I'm going to use Cassandra, or I'm going to use DynamoDB, or whatever it might be for your project. You just say, I'm going to use the key value interface. What's on the other side doesn't really matter. And this also allows you to do some cool things. I would use SDKs for free. So the whole point is that you get this entirely for free. You can write an SDK once. Imagine like the Go library for Kubernetes. We all have probably experienced that time where it's like, oh, I need a client for such and such language, and you find it and it's half-baked or only part of the way created, and then they all have slightly different functionality. In this case, you can define it all behind an interface and then write it in whatever language and use it from whatever language. There's also this cool thing called virtual platform layering, where you get to choose what plugs in and to abstract away things that you don't want for your users, or for a piece of code to be able to access. So let's do this in terms of like I said, I'm trying to keep this diagrams. My slides are just diagrams here so people can understand. Let's assume we have two components here. You could have a component written in Go and a component written in Rust. So in this case, you might have these things that saying, I need to access like IO. I need to be able to do streams and things. And I need file system access. And I need to access the environment. Well, there's a lot of things in there that you might not want to do. But then something else like HTTP might just be provided by default by your platform. So you could write a custom thing in Go that does some sort of custom implementation for your streams, and then does like an in-memory file system. It could use Go embed or something like that. And then in the environment, rather than passing all the environment, you can specify, oh, I'm only going to expose the environment variable foo, which has a value of bar, to this component. Now, the component didn't have to know that it's being composed with something else. It just essentially clicks together like this and becomes one new component. And so that's the powerful thing we're talking about here. Now, that's a lot, but like I said, I'm really just going to let Jochen and Tyler show what this is. But one last thing to understand is about what wasmCloud is. Where does wasmCloud fit into this? So if I go ahead and show that, what we get is this thing like we can build something, compose it all together, and then run it. And we like to use the Lego blocks analogy, but you can essentially say, I'm going to take something and run it in a distributed way. So wasmCloud lets you take these components, any component that meets these component standards, and run it in a distributed way. You could say that wasmCloud is the Kubernetes for WebAssembly. And so it lets you take these things and run them anywhere. So you can say, I'm going to build my business logic. I might build just this little tiny piece up here at the top where it says, just build this bit right up here. And then after that, I can compose these together. I have these capabilities that I'm given, like WASI key value or Postgres or messaging. And these things can then be technically running across a bunch of different machines. Everything in wasmCloud is a flat network topology. It doesn't matter where it's running at. And what happens is you have something like, oh, I'm going to run it inside two different Kubernetes clusters. And then I have an on-prem data center. And then I might have a bunch of edge locations. And the different pieces of the application could be running on different parts of basically the whole world, and then have something connect back. And you'll see this live in action from Jochen and Tyler here in just a second. So that is the super, super fast review of this. Now we do have a question before I move on. We had a question that was, can this be applied to digital twins data ingestion? I think I have an answer here, but I also suspect that Tyler and Jochen might have an even better one since they do this as their day job. Do you guys have a good answer for that? You're all shut
Yeah, I mean, in principle, yes, data, digital twins. That's one. It's a data model basically. It's how you treat the data from a machine and how you reflect that into your in your domain. So it's entirely possible to do that with digital twins. We have a sort of digital twin, kind of we treat a machine as the subject that we observe and that we actuate on. So yes, answer is yes. You can totally apply that and use that with digital twins.
Yeah, and like to add on to that, I find this is one of those things that we hear a lot from people who are doing especially edge stuff. If you're doing things behind an interface, you can easily swap out a digital twin. You could be talking to a real device or you could be talking to a simulator. And for all intents and purposes, the code doesn't have to change. You just compose that in. If you're saying, oh, here's my, like sensors interface that you've defined, it's a custom one that you have inside of your company, and you are receiving data from that could be plugged straight into a capability being provided by that edge device. Or then I could take something and say, I'm going to write this simulator, or I'm going to plug it into previous data, to test it and see what it was like. Any of those things can be done because it's just composition in the end. And there was a follow-up from that question in chat. I'll read out. It says, so I would not need Kafka. Yes, you could get away without Kafka. Kafka could be behind this. But once again, it's behind an interface that people don't have to care about what the implementation is. You as the platform person who might be saying, I normally do this with Kafka, will care, but the developer writing the business logic doesn't have to. Okay, so with that, I believe Tyler has some cool stuff to show here and talk about.
Yeah, thanks for that introduction for some of the WebAssembly and wasmCloud bits. So Jochen and I are going to talk a little bit about how machine metrics came to WebAssembly and wasmCloud, some of the whys that our organization is deciding to pick up some of these technologies. We'll go through like some proof of concepts that we've worked on, a little bit of demos, how we're using some things in production now, and some of our plans that we have going forward. So yeah, to get into the why. We run a lot of edge devices connecting to manufacturing machines. And at those edge devices, we're not currently able to support Kubernetes at that deployment platform. We're running an operating system right now that only allows us to deploy from Docker. So running Kubernetes within Docker creates a pretty weird inception layer and lots of performance overhead that we don't want to take on. As well as if we wanted to reflash the device, that's something that would require our customers to spend a lot of time, lengthy process. We don't want to require them to go through. And just generally speaking too, Kubernetes is great. We use it a lot in the cloud, but it's a little heavier than what we need on our edge devices. That kind of gets into some of the limitations that we find on an edge device, since they're not the most powerful compute like you're expected to have in the cloud. So another great thing is the security model, right? So kind of like what Taylor mentioned, WebAssembly was born on the web, has a great sandbox environment that sets a really high bar of security, denying things by default, which is really becoming the expectation for a lot of our customers, especially those working with really sensitive data or government contracts. We need to be able to guarantee them that nothing's going to be compromised with their data. And we have a huge range of customers, from those who have massive IT teams to some smaller mom and pop shops where security is not all that big of a concern, and we kind of have to treat that as the expectation for all. So we really need to be locking down and handling everything on our own. And then also we're starting to actuate on machines, right? So we'll go over like a little bit of a demo of that in a minute. But it's very, very important that we don't have any malicious actors that can, get into our space and then, take action upon a machine running in one of our customers' shops. So in terms of efficient execution, right, WebAssembly is really, really fast, lightweight, and that's great for our edge deployment platforms, just because, like I mentioned, these devices do not have a lot of resources. We're talking like 2 to 4 gigabytes of memory, low CPUs. And so to be able to deploy these really small little Wasm modules gives us a lot of confidence that we can continue to push compute on the edge, which is something we're not doing quite as much of yet, but we would love to do more of because it's a great opportunity for us to bring compute closer to the customer, and then also just reuse some of those available resources rather than just offloading everything to the cloud. And then in terms of again on actuating machines, right, we have latency requirements. If we need to stop a machine quick, having to go through the whole pipeline to the cloud, get evaluated, work its way back down, can be a really slow process. I mean, still in terms of like seconds in the average case, right? But that might be too long, where if we're able to bring more computation right to the edge device, then that lets us have much better turnaround times. And then, like I mentioned, that 5 to 7 seconds of average, network round trip is the average case, but there are certainly times where we find that we have low bandwidth, and it can take a long time for things to go to the cloud. And so to be able to keep things close, great there. But then also deploying things, right? Like if we want to, if you're dealing with something in the size of like a Docker image, that could take a very long time to pull over the network, where when getting into, WebAssembly modules, really, really small, like we're talking like kilobytes and things that can be easily sent over the wire. I mean, you can send full versions of applications just like right over the wire, which is a really, really powerful thing in our domain. And then a little bit specifically to the wasmCloud side of things, wasmCloud runs on top of NATs, which is a technology that we've already been using. So for us to jump into wasmCloud was kind of a natural extension, since we had a lot of the infrastructure already in place, and then can just continue to kind of build on some of the great principles there in terms of distributed compute, and really not having to care about where your application is running. Yeah, and I see there's some questions coming through in the chat, and we definitely encourage that. We want this to be as interactive as possible. Should have said that at the beginning, but go ahead and pepper them in as you would like.
So we have this question so WebAssembly can handle confidential containers. I think I'll take this one. So they're kind of different technologies. They can solve similar problems. WebAssembly can be run in anything. It can be run on bare metal. It can be run in a container. It can be run on a VM. But essentially, you can make it very confidential in the fact, like the whole idea of like locking it down and only certain things can access it. You can very much do that with WebAssembly because it is that deny by default that Tyler was mentioning. You're able to explicitly say, and you can tell when you receive a WebAssembly component what things it's trying to import and export. So if you see anything that you're like, I don't trust that, or you say, you can have it, but I'm giving you a limited version, you can do either one of those things. So it's a little bit different than like normal, like confidential or compute, kind of like that kind of thing. But there's some overlap in some of the things that it can do. But you're also it's entirely possible you might want to run like, if you have like some really, really super secure thing and you need multiple layers of sandboxing, you could run WebAssembly in like a Firecracker VM or like a Kata container or something like that.
Awesome. Yeah, thank you, Taylor. All right, so now we can jump into a little bit of a use case that we have at Machine Metrics. So this is around tool monitoring. So you can see the image there on the left is just a CNC lathe that's machining away that spinning part right there. And then on the right, you can see tool load. So over time, right, you have this cutting tool working on metal, and the tool will slowly start to wear away, become dull, and then it can kind of just fail in spectacular fashion. And tools tend to be expensive as well as the parts that are being machined. So it's great to find this balance, ideally, between how long you're going to run your tool before you choose to change it, so you can get the maximum life out of the tool without scrapping the part that you're working on. And this is a really common problem that our customers have. And so we've been looking into some ways to solve this. And you can kind of see on the right, as the tool load continues to grow and grow and grow, eventually, bang, that breaks. So this is something that we've been looking to work on. And it is computationally very expensive, and again, actuating on a machine to stop it so that the tool does not break and we can save the part is another great reason to look towards a technology like WebAssembly. So we implemented a downsampling algorithm that uses the largest triangle 3 buckets algorithm in a stream-based fashion, so that we can downsample the data, the high frequency data that's coming at the edge, so that we can still use it for an application such as tool monitoring right there at the edge. So you can see on this little diagram here, you know, from 5,000 data points down to really just a handful, you can still represent the curve really well. So you don't really miss some of those important data points, but you can deal with a much smaller data set. And if you're curious about more into this, Johan and I did give a talk at Wasm Day at KubeCon in Paris just a few months ago, and that video's on YouTube, so you can check it out to learn a little bit more. But now I'll hand it off to Johan to talk a little bit about some of the architecture behind this.
Mm-hmm. Yeah, so as Tyler and Taylor laid out, we have architecture such as edge devices on the factory floor, and we're in AWS, we have our cloud provider, right? And for the proof of concept where we tested whether wasmCloud actually works for us, we split that up, and we have, as we talked about, NATs as an underlying technology already going. So our machine data comes through a NAT stream and is available on the edge and in the cloud. And we call that SCADA. That's machine data, essentially. And there's wasmCloud streams, and there's streams that are key value buckets that can handle configuration and cache. So for the demo, for the proof of concept, that's our setup. We only have Kubernetes running in the cloud, as we mentioned. And we can put now a wasmCloud host that runs wasmCloud on the edge device. And as you can see here, we have implemented a data sampler, downsampling algorithm as a wasmCloud component. And we want to connect to our NATs, SCADA data on NATs, which we do through a so-called provider. This is basically, wasmCloud lets you deploy providers that connects to infrastructure that cannot be directly compiled to, or the libraries that you use cannot be directly compiled to WebAssembly just yet. So you can have this hybrid. You stand on the host, basically. It's host implementation, host specific, but everything that's running then in wasmCloud as a component, like the data sampler, is agnostic of where it runs. So you program, as a programmer, you program just against the interfaces that the NATs message provider here or the NATs key value provider gives you, right? And so we basically get the high frequency data through the NATs message provider into the downsampler and the data sampler. We then downsample it through the algorithm, put it back as sample data on the SCADA stream. And the algorithm is based on kind of building up data and then select the best event to represent something, which we realized with the NATs key value provider. So it's just also running on NATs. It's just a cache as a key value bucket. So we buffer data. We also use the NATs key value provider as a distributing configuration, what we will see. And wasmCloud gives us the ability to run that, and also to deploy and kind of what we do in Kubernetes, describe our applications and use a tool called Wasm, right, that you see here, to deploy our applications on the edge. We could also deploy it in the cloud, so it's very movable, right? So, and I think on the consuming side, what we will demo is a UI that shows the high frequency data and the downsample data. And one of the things that we have here in the cloud and running on Kubernetes is a Grafana instance that shows the sample data. This you can just manipulate and look at. Then we have the configuration can also be manipulated directly from the browser, in the browser, to NATs. And that kind of allows us to have configuration being manipulated anywhere and also consumed anywhere and on each of the edge devices simultaneously, right? So, and I think, Tyler, you can take it away with the demo.
Awesome. All right. Yeah, so I can kind of walk you guys through a little bit of a demo showing this off, just using some test data. Obviously, we can't show customer data going through doing this process, but the process is very similar, despite everything just kind of running locally on my machine.
Hey Tyler, could you like hit Command
Um,
plus on that terminal like
yeah, for
5
sure.
to 7 times?
Yes, no doubt. Let's see.
Yeah, if there's people who've maybe heard me say this before, I always go until I think it's too big and then go 2 more. And that always seems to be big enough for everybody.
Is that big enough? It doesn't seem to let me make it any bigger.
Yeah, perfect. That'll
Perfect.
work.
Oh, yeah. Well, it's going to have to. Okay, great. All right, so the script I'm running right now is just starting up NATs and then a high frequency simulator. So this is just to kind of represent what an edge would look like. So we can see here, if I subscribe to raw, we're pumping out a bunch of high frequency data. This looks relatively similar to some of the data that we would be producing at the machine level on NATs. And so if we want to take a look at this on a tool such as Grafana, this is a good example of where you can kind of run into a little bit of trouble. All right, let's see if this will load up for me, or if I need to. Let's go into our connections. Sorry, this is a little. Let's see, localhost 4001. It's a little plugin for Grafana that we wrote to use NATs as a connection, so we can take a look at the high frequency data that's being produced here. And so at this kilohertz rate, we'll see that this will start to slow down, and it really gets into a fashion that's not quite usable. As you can see now, it's starting to lag and really come to a crawl where it just about dies. And that, again, another great use case for downsampling. So if we go back over to our terminal, we can start up our downsampler. So all we're doing here is starting up wasmCloud in WebAssembly. So I can show you a little bit what this script is doing. Just starting up Docker, which is going to be running wasmCloud in WebAssembly, and then we will use the wasmCloud shell CLI wash so that we can deploy our app. And that manifest is, I want to make sure this is nice and big. This is still using, it doesn't need to be upgraded to wasmCloud 1, so this is 0.82, but its definition is not all that different, right? So we can, define our data sampler application, and then we can provide those capability provider components that Johan was talking about, right? So we can have NATS messaging, as well as a key value store to store some of that distributed configuration. So if we go back over to our terminal, we can check in on the application and see that we are deployed. So that now if we go on to sampled, so this is just going to be doing downsampling, so taking whatever is on that raw subject, and then it will spit it back out on sampled for that given machine. So you can see that what was once that ripping through amount of high frequency data is now being downsampled through the nice algorithm that we have running on wasmCloud. And then if we were to go back to Grafana, should have left that open, and we take a look at sampled data, then we're dealing with much smaller data points, again, kind of representing the same curve. But this gets into something that is actually usable, right? So we can use, Grafana is a very common tool, something that we use. Some of our customers have dashboards in Grafana, and we would want them to be able to visualize this data. So to take it a little bit one step further, we can take a look over here. We have side chart UI, which will show the side-by-side data and let us manipulate some of the configuration on the fly, which is really cool. Sorry about that. log ourselves in, right? Okay, perfect. So yeah, you can see in the red, that's the downsampled data. And then in the blue, we have the high frequency data, which does display here really great. So this SciChart application actually uses WebAssembly in the background to handle this data. So unlike Grafana, it is able to keep up without crashing. But right here, we're able to tune the lag here. So we can slow down our maximum lag. And this is just manipulating the same key value bucket on NATs that we're using as configuration running in WebAssembly. So we're here in the browser able to manipulate configuration that's running on the edge, and you don't have to think about it at all. So it's super, super powerful, just, the distribution there and how nicely everything kind of comes together. And so like, as we can speed that up, you can see the red catches up. And we can see that too if we do a NATS KV watch on the max lag here. So, as I tune this and jump back over, you can see in real time, we're making these changes over here. So it's a super, super powerful model that just comes together really, really cleanly. So yeah, that's about the demo that I have to show, and kick it back over to Johan to talk a little bit about. Actually,
you want to show your WebAssembly module?
I do have another thing to show. That's a great point. So this was a great proof of concept for us to kind of validate that like WebAssembly and wasmCloud are great tools for us to use just for so many reasons on, really opening new doors for compute, like doing high frequency data visualization and processing on the edge was, something that was challenging for us, if not almost impossible, right? And this is enabling us to do things we couldn't do before, as well as opening the door with new architecture models, right? Because with wasmCloud, you don't think about where your compute is. You can just run things, and if it's on the edge, it's on the edge, and if it's in the cloud, it's in the cloud. And then being able to, write in language agnostic ways, the SDKs for free. So normally, our distribution of people running things on the edge, all writing in C++, and that being a requirement to run things on the edge, right? A lot of that technology, it's easier for teams to kind of manage features end to end, just in whatever language that they're using. So another use case we have is something I can show real quick. This is just a little module that I wrote that we're using in production now. Won't go into too many of the details there, but it's really just, deals a lot with like interval slicing and categorization based on like what was happening, so that we can report out like how intervals of time are being used and generate metrics based on that. So it's really just a black box calculation. And for us, this was a great use case for WebAssembly. So we wrote this module in Rust, and then produce a WebAssembly component from it. And then we're using Node in our backend, but we can compile this using some of the great tools from the Bytecode Alliance, so that it kind of creates like a nice little Node wrapper to expose this WebAssembly components functionality within Node. Which is a really awesome case because we can, this is computationally expensive and something we want it to be as performant as possible, but also sets us up for some great things down the road, right? So this is our WIT file, probably about as simple as you can get, right? It just, exports this get function, lets you pass in, just some dates and then some additional JSON metadata. And then what we do in the background is compile this, take the Rust code, compile it down using the WASI compile target, and then use JCO, a tool from the Bytecode Alliance, to do some of the Node related stuff. So it kind of just handles all this in the background, but ultimately just exports your function. So then we can have a small Node module that just exports it. And then we can import that in any of our Node and JavaScript processes, which is a majority of stuff that we have running. But what's great about this is that while it lets us find performance gains and do some expensive things, better than Node would do, as we look to expand how some of these models work, it would be really easy for us to take this component and combined it with something like an HTTP server. So then this can sit on wasmCloud and we could handle like request responses. Or if we want to bake this into other pieces of business logic, then we can again compose those components together, and then we don't have to do anything more. This was written in Rust, but that could be something that's written in JavaScript or C++. And so this logic is just reusable really whenever and wherever. And it's been a great use case for us, and we look to continue to build out additional cases like this going forward.
So Tyler, I'm just going to ask. I obviously know the answer here, but I'm going to ask the dumb question. So you're showing this WIT thing. Like, was this a pre-existing interface you had to use, or is this something just entirely new that you created?
Yeah, I just wrote this. Yes, I just wrote it. It exposes that one function, and like in the component model standard, right? That just shows this is what I can do. Normally here you could also expose this is what you might need. It kind of goes back to the little diagram that Taylor showed earlier, where you can kind of see the components like nesting into one another, and that helps you fulfill like those imports. And yeah, as like in the example of like laying it with, an HTTP server or some other functional component, right? Like if you had a business logic component that needed this, then you could require that this functionality be provided. And again, you don't have to know anything outside of just fulfill this requirement for me, and then I'm ready to go.
Yeah, and that's something I asked that because that's a key thing. A lot of people go, well, didn't we try this stuff before with things like Corba? People are like, oh my gosh, Corba, you're mentioning that. But like, and I'm calling that out. Like the point here is you can define custom interfaces and then adapt and compose all of them. So like that's something that's really key that I didn't want people to miss who are watching the stream, is that this wasn't something like wasmCloud provided to them because we have our own interfaces, or that had to be a standard community centralized one. This was one that you guys defined for yourselves for a specific use case you had.
Yeah, exactly. And picking up WIT is easy. It feels familiar. And yeah, it's great that you can write all of this, just strict WebAssembly component logic, and then this pairs so nicely with things going on in wasmCloud, especially as it just becomes, it's really component native, adheres by the same standards. So for us, like, it's great. This is a perfect use case, and a good example too of like being able to start small, and this serves an easy purpose for us, and isn't all that complicated. And then as we want to use it, the possibilities are really endless.
Mm-hmm. I want to just mention also another option is that there is an existing well-defined interface, for example, for a key value bucket or for messaging solution. And you have a technology like Nats or like Redis or something that provides that, but you want to abstract it away. So you can adopt an existing interface that's well-defined and write your implementation against it. And then therefore give essentially back to the community kind of an ability to connect to Redis, to Nats if you need a key value bucket, something like that. And so this is also awesome. This is just a small interface that you can write yourself. You can also import existing interfaces and implement against those. Right?
Awesome. Well, before we jump over back to, I think, Jochen, you were going to keep going. There was a question that came in right as we kind of launched into the demo. And so it's going back to some of the things you were showing off, Tyler. I'll show it here on the screen for everyone else to see on the stream. So I was just curious, because this is something that I know a little bit less about, what your guys' answer would be to, can WebAssembly support smart manufacturing and any like ISO compliance issues?
Yeah, so there are two separate things. Like WebAssembly itself is completely neutral or agnostic to whatever you use it for, right? For any compute. And of course, we adhere to certain standards. We adhere to certain kind of messaging standards. We use cloud events, for example, to express all our events that we send over NATs. And that is basic. And we use a structure that is kind of well known in the unified namespace. Kind of, we have a unified namespace. We expose our machine data through MQTT, which, by the way, comes also out of the box with NATs. So that's why NATs is a really awesome technology to use for manufacturing, right? And so those things, we adhere to those standards, right? And provide the data downstream to our customers if they want to plug in directly NATs, right? And WebAssembly for us is a way to connect to our machine data, process the events that we get, either on the machine level, also from ERP systems, and so on. So we do that, and we will expand kind of new things will be developed in WebAssembly and are reusable in many different contexts.
Awesome. So that was a good answer. So Jochen, are you ready to go ahead and
Oh, yeah,
go ahead
sure.
and bring your stuff back on
So
here
we
for
switch
you?
over? Yeah.
Yep.
So this is, again, architecture a little bit. So what we're planning, what we're currently developing, and as Tyler said, a recommendation that we have is test it out for you in a kind of a proof of concept that's medium complexity. That was for us the downsampling algorithm that showed kind of how all the pieces work together, and then start really small to implement it, but think big, right? Think ahead. How the architecture will look like. And so this is a little bit of a taste of that. And Tyler showed the start small, write your with interface definition, right? And then implement something that is usable immediately in your business that you write once in Rust and then can deploy for Node.js or in other Rust or in C++ projects, right? And that was a main selling point for us to the business. Like, oh, if we use WebAssembly, we don't have to spend the engineering cost in basically implementing some kind of NATS connector in different languages, because we are a heterogeneous environment, like Edge device, the Edge team mostly programs in C++. So this was a main selling point for us. So start small, do something like that is immediately useful, and then expand on that and try go larger and larger. And we don't have the ability to go on a green field, kind of from completely from scratch. We have Kubernetes environment, we have existing infrastructure in AWS like Lambdas, and we have existing Kubernetes services and pods and deployments and so on. And some of them you see on the screen here. And it's the same kind of basic setup. Left is Edge device, on the right is the AWS cloud and with Kubernetes inside of it. And on the Edge device, actually, we have a custom supervisor running that supervises our containers that are running, an adapter or many adapters that connect to machines, and a tool monitoring container that basically gets the high frequency data and then decides whether a tool is about to break, as you've seen. And this information, like, oh, a tool is about to break, this information as an anomaly is put onto our SCADA stream. So it's available everywhere, right? And so it can be then consumed on the right side. I don't know if, yeah, you see my mouse pointer. On the right side, it can be, for example, traditionally you would think you put it just in a database and then make it available, right? And then send out a notification through a Lambda. So this is a long kind of winding road through the infrastructure, and that's essentially a little bit how it currently works, right? But we wanted to introduce WebAssembly, and we have the first step that we did was, now we want to react to those anomalies and send out emails and text messages, depending on how that's configured, right? A user in our application can select, oh, if you see a tool anomaly, send me a text message, right? And this is configured using the dashboard here, put some configuration in Postgres and makes it available through a tool called Hasura, which is a GraphQL implementation. So when you see Hasura here, it's behind that, but Hasura is essentially our GraphQL, right, API interface. And the first step that what we did is we are running wasmCloud host on Kubernetes and using wasmCloud operator. We can talk about that later. And here is a monolith, basically. We just started to say, okay, put all the logic, like listening to those anomaly events and notify our customers in one big blob, basically. That's not big, it's very small, it compiles down very small. But our GraphQL kind of access is just delivered through the HTTP provider. So we send out an HTTP request to an Hasura GraphQL endpoint. So that's the first step that we did, and that this is already implemented, it works. So, and the listening to the anomaly events is done through the NATS provider that's already existent, right? So both are basically provided, community provided. So we're reusing community components here, right? So the next step for us would be to kind of the notifier agent Lambda to get rid of that and send directly emails and text messages out with email provider, a Twilio provider. And here it's displayed as provider, but most likely it's just another component, right? That we use, a kind of inside wasmCloud. Everything can be compiled to WebAssembly on that level, right? So we don't actually have to use a provider, which is this, as you remember, the hybrid between the host environment. So it runs on the host environment, but provides an interface to components in wasmCloud. So so direct connection, the main point is here, direct connection through an HTTP provider to the API endpoint. Now, every developer that develops a component like the monitor and notifier will have to write that kind of code again and again to connect to this specific API endpoint. And what we would like to do is abstract it away and say, oh, just basically use a GraphQL component through the interface, right? Run query. And that's it. And all the kind of login and the credentials management and so on is done within that encapsulated component. And this is basically here, displayed here. You have a GraphQL component that just exposes the interface, run query, and the monitor notifier just imports that interface, and you can just give it the query and it runs it. Under the hood, it still uses here the HTTP provider, but the monitor and notifier does not have to know anything about how it's actually executed, where it's sent, the credentials management, and so on. It's all done within that component here, right? So, and as the box here around it kind of signifies, you can put them together into one component, right? If you want to have treat it like a library more, the GraphQL component, then you can just kind of import it and put it together into one component that you treat as deployment artifact, right? This is an advantage in kind of how it's very close, it's very fast, reduces complexity in the deployment and so on. But it also, if we wanted to shift the compute of the monitor and notifier from the cloud environment more to the edge device, and Tyler said that with the latency, so we want to be fast sending out emails. We don't want to do the round trip to the cloud and so on. We want to shorten that. Then we can move that over here, kind of run the wasmCloud host, essentially bare metal, right? We don't have Kubernetes. We run it bare metal on the edge device. And the modern notifier still needs the GraphQL configuration data. So where do you need to send the text messages? Who wants to know about it? How should we react? All right. And so this information is we still need our GraphQL API here. But what happened now is that our Postgres database is only available in the cloud. We want to keep that GraphQL located in the cloud, right? And everything runs here still. We can still call the GraphQL, but now without changing anything in our component here on the monitor notifier, we basically send this kind of message or this function invocation over WRPC, which is something wasmCloud offers, right? Over the net, and the GraphQL component will pick that up, execute it through the HTTP provider, gets the necessary data, and out WRPC with the answer and to our monitor notifier. There it can be cached, so we don't have that latency problem. Everything else is basically local to the edge device, right? So we have architecturally with wasmCloud a lot of freedom to move compute where we need it, right? For example, for the reasons of latency, we also can have our compute or our execution here next to the database where we need it, right? And kind of compose those things as we need it. And that's a really big thing. So that's what we will do more and more with our kind of architecture, that we have more freedom and move things around where we need it, right? So I could go on, and maybe there are questions to that. Put them in the chat if you have questions to that architecture, right? And maybe one last thing that we can talk about is, and we can open up the chat and questions, is the wasmCloud operator. So when we run wasmCloud hosts which then executes the Wasm components. We have in the cloud already a Kubernetes cluster. So while wasmCloud gives you the ability to run on bare metal or any infrastructure, it also has a really cool wasmCloud operator on Kubernetes that manages the wasmCloud hosts on Kubernetes. And I can show you how it looks like in the background. If you know a little bit, we're using Argo CD as a deployment, and it looks like any other basically deployment. And it gives you here, in our case, we said we want 3 wasmCloud hosts that we can run our components on, right? So it lets us easily manage the wasmCloud hosts in our existing environment, and you can deploy applications, and they show up as applications here on Kubernetes, and you can use all your tooling, the logging, the kind of monitoring that you have in place for those things as well. So while we're not bound to Kubernetes to run wasmCloud, we can use it with our existing tooling, right? Which is awesome.
So, Jochen, there was a question that just came from chat. So let me show that first on the screen. I'll let you take that.
Can a far edge be on the other side of the edge? Far edge. Okay, so depending on what you mean by far, I assume that kind of edge behind the edge. So chaining things together. Yes, you can, because it depends on NATs, and NATs has a very, very powerful way to define topologies. We use NATs as a so-called leaf node on the edge device, and there can be a whole cluster of leaf nodes, right, on the factory floor. So you can have many leaf nodes being together as one cluster on the factory floor, and we have our main cluster or several clusters in our cloud environment. So you might want to have one on the West Coast and on the East Coast and one in Europe because of latency, right? You can specify with NATs very complex topologies that allow you basically also to daisy chain clusters and so on. So yes, this is totally possible. It's indirectly a benefit of wasmCloud because wasmCloud uses NATs underneath, right? And therefore you get all the benefits of NATs with wasmCloud.
Yeah, and speaking as like the wasmCloud maintainer here, like what Jochen is highlighting is really we really try to make sure we maintain separation of concerns in the various parts. So people who are maintaining platforms are the ones who provide, these providers, these plugins that give you functionality on a host. And then the network, like wasmCloud, doesn't care how the traffic's getting routed to it. So a wasmCloud host is actually fairly there's not a lot of smarts there. What it's doing is taking advantage of NATs. And so you can reshape your traffic, like actually live. There's actually things in NATs that allow you to like split traffic and do things, really cool things with it. You can reshape how your network is delivering the things to wasmCloud without wasmCloud even knowing, and doing it on the fly. And so it's just maintaining those separation concerns because we don't want to reinvent the wheel. Where wasmCloud tries to focus on what we're good at, which is basically running distributed WebAssembly. And then we use the technologies around that make it work really well. So you can basically architect it however you'd like. It's as flexible as you're willing to go with your essentially underlying NATS infrastructure.
Mm-hmm.
I had the question for you, Jochen. So you were showing that thing in Argo. So I know this because I've seen you show the Argo things before. So you're able to maintain both like the infrastructure of the wasmCloud host, but also applications, correct? You're able to send applications through the wasmCloud operator using like the WDAM stuff you were showing earlier, correct?
Correct. Yes, I can't show it here at the moment. That's because it's restricted. But yes, you can see the underlying kind of the infrastructure for wasmCloud. That's what you're looking at here, right? You can manage that easily with the tools that you have on Kubernetes. We use Argo CD, right? But you can also manage your applications across that with your usual Kubernetes tools, right? The WDAM that we showed to define the application, that's going to be just applied, and then it shows up in Kubernetes, right, as an application, and you get all the tooling there that you need. So it's a really interesting way to kind of not you don't need to take a huge leap and say we leave everything Kubernetes behind. You can just integrate it with Kubernetes as much as you want, right? If you want to take a leap, you can. For us, it will always be a kind of, it will not replace Kubernetes, because Kubernetes has other use cases for us, that we run our database infrastructure in Kubernetes. We see wasmCloud as kind of the next step, making it more lightweight. You can run it on Kubernetes, you don't have to. And for us, that's a real benefit. We can run it bare metal on our edge devices, right? And it integrates, so you don't see, our vision is basically to not talk about edge and cloud so much anymore, because it vanishes basically. The differentiation between edge and cloud goes away, right? Traditionally, where we come from, we have an edge team, we have a platform and cloud team, right? More oriented, and they're separate, right? Because they use separate languages, they have separate deployment kind of strategies, and this will unify it, right? So you build your applications as a WebAssembly component, and then you don't even know where it's going to be deployed, right? Essentially, you can definitely tell where it should be deployed, on all edge devices or just on those with a specific label. But essentially, it breaks down this barrier between edge, cloud environment, or other cloud environments, right? Separate cloud environments, like if we would want to kind of connect to Google Cloud or something like that, we could. It's neutral. It neutralizes this difference.
Awesome, that's great. So we're getting close to the end. Were there any other questions? If there are any other questions, please drop them in the chat, and we'll try to get to maybe at least one more. Was there anything else you wanted to? We can also just start to close up as well. Was there anything you guys wanted to close up with, or show, or say as we wrap up here?
Basically, I just want to encourage, if you're IoT company or any company, pretty much try it out. Yeah, test it. Whether it set up a little POC like we did. Put in some and find out if it works for you. It works for us. So I think IoT is one of the prime use cases of that stack, right? Wasm, WebAssembly, wasmCloud, and Nets, right? So just try it out. And there's an awesome community in the wasmCloud community is awesome, really helpful, kind of responsive in Slack. It's kind of very friendly environment to get started, right?
Yeah, to kind of add on to that, I mean, the community really is great. I guess to plug the community meeting too, that would be in 3 minutes from now. So you could definitely recommend joining the wasmCloud Slack. You know, the maintainers are super active in there, but the community is continuing to grow, where you can find a lot of help from others, and it's also, you know, expanding libraries, right? Like the downsampling algorithm we showed, we wrote a provider for Nat's key value. That's something now that's just offered out of the box, and I think that wasmCloud and WebAssembly, you know, sounds like it could be a lot, and that there's a big barrier to entry, but it's very approachable and something that you can do right now, whether that's small use cases, big use cases. And like Johan said, it doesn't have to be greenfields. You don't have to re-architect your whole application, but you can, you know, it's been made easy for, you know, organizations of all different shapes and sizes to start to take advantage of, you know, this really awesome new technology.
Awesome. Thanks, Jochen and Tyler. And then last question we got from people is basically like, how do I get started if I'm new to Wasm and wasmCloud? Well, we've been working a lot on documentation and stuff to make this clear. And I will show this on the screen so people can see it. If you go to basically wasmcloud.com and click on docs, or just go to this link, the wasmcloud.com site has links to the repos, which is just wasmCloud on GitHub. And it has links to the community meetings and the Slack. And then we just like literally yesterday or the day before pushed a whole bunch of new updates and clarifications to the docs. And it explains everything about like, what is WebAssembly? Like what's a WebAssembly component? How does it work? What is this WIT thing? How do I get started with wasmCloud? We're trying to put as much of that material in there as possible. And to be clear, wasmCloud is very, very focused on the standards. We want to make sure that we are always standards compliant. And so everything you do is transferable knowledge inside of WebAssembly components. if we're locking you in, we did something wrong. We want you to use like us as a project because we add value. And so that's how I would recommend getting started, is just checking those out. And then, like Tyler and Jochen said, we really do have great community stuff. We have good conversations in Slack. In fact, that's where probably all three of us are going right after this, is to the wasmCloud community meeting. So we always have that every Wednesday. So anyway, that's just kind of the update, and we invite you all to check it out. Thanks again to everyone who was participating. This was a great live conversation. Thanks again to Jochen and Tyler for all their work and showing this off. And we'll see you all at the next Cloud of